Perfect. Okay, so I'm Carlos. Today I'm gonna chat about using Kotlin Multiplatform for analytics. So before we jump in, just quickly a little bit of introduction about me. I work at Prezzee, it's a mobile tech lead, and yeah, I've been working in the industry for a little bit of like 10 years or plus. And before jumping into the how we are prototyping these analytics using Kotlin Multi-Platform, I'm just gonna chat a bit more about the context of why we're doing this and what the problem is. Just to start with, um, we have right now an application or two application, an Android and iOS application for quite a bit of time, like 5 to 6 years old. The Android one is written on Kotlin and Java, and the iOS one is in Swift. We also started modularizing our apps for probably 1 year ago. So we got a bit of different modules on our Android app and on our iOS app. So this initiative is also to continue modularizing, like to have a proper analytics modules separated from our main application. We also have a bunch of different analytics data destinations. So before, like in the early days, we only had sending events to Firebase Analytics, but now that got a little bit more complex. We are sending actually data to different places. For example, we use Segment as our data platform, so we're sending events to that. And we're still sending events to Firebase Analytics, so for developer events to do some stuff there. And we also have different fraud systems integrating into our application so that we can get smarter at fraud detection. So yeah, it's not simple, the analytics part anymore. Also, that is very important for us, and we actually have a data team looking after the tracking plan. So they look after that the data that we send from, or the data that is sent from different clients is consistent and it follows the specifications, so that they can actually use it and create different reports for the business. So it is a very important part of the company. So what's the problem, right? If we got already some analytics part of on Android and iOS and everything's working fine, like what's our problem now? The problem that we're having is like it is very easy to introduce errors, and if we got an error on our analytics part or some events are missing some part of the information, it's going to create a lot of violations on the data, and it's not going to conform to the tracking plan, and therefore there will be missing events from our clients, which will result in all the data processing on the data streams won't have any events to report on. So, and that's due to we don't have probably enough test coverage. Like the analytics part is not tested at all. So that's one of the problems that we're having. Another problem that we find is that we also have some inconsistency between our different clients. Even just between iOS and Android, we have some inconsistency. But if we compare also with the web part, it might be even more inconsistency across the three different technologies, which this complicates a lot of the communication with the team to say, hey, is that a bug, or is that something that we forgot to implement, or is that in the tracking plan, is something that we didn't do? So yeah, a lot of inconsistency there. So why Kotlin multi-platform? So you might be wondering, I guess for some of you that haven't heard of multi-platform or Kotlin multi-platform, is it allows teams to share common code, the common Kotlin code across multiple platforms, and iOS, Android, and even on web. It also allows teams to choose when and what and how much you want to share. Compared to other technologies, you have basically to share everything and then opt out. What multi-platform gives you is a lot of flexibility of what part of your application you want to share, which means that you can have a progressive adoption. You don't have to migrate everything to multi-platform. You can just start small and then keep iterating on top of it. another thing is that the developer experience is very similar for Android. So if you're already developing an application for Android, there's basically not difference at all for them. It's a little bit less for iOS because yeah, you might have to use different tooling like IntelliJ IDEA or Android Studio. But if your iOS team is already contributing to the Android platform, then they won't have any difference. Low risk. Why low risk? Because in the worst case scenario, if you create something multi-platform and it doesn't work, that code can be your Android module, and then just it's an Android module itself, and then you could probably implement the iOS part in Swift. Just in a nutshell, how multi-platform works is that you have a common Kotlin code, a common module, and using the Kotlin JVM compiler or technology, you're gonna generate a jar library or AAR for for Android specific library, and then you can use that on your Android app, or using the the Kotlin native compiler, you're gonna generate a fat framework, universal fat framework, or even an XC framework, and integrate that on your iOS project. So that's kind of the basic functionality of this. So now jumping into the prototype of the analytics, how does it work? So as I said, we have two applications, Android and iOS. And what we did is to create a different module on multi-platform, right? So how does it work? So this purple box is the module on multi-platform, and basically you have something called the common main, in where you write Kotlin code, and the objective is to have as much code in this part, because this is shared across all the different targets. So the way it's structured, this common main module for the analytics, is that we have a bunch of data models, which is, for example, the definition of what is an event, or what different events do we have, what different properties each event has as well. Then obviously our library definition, what the analytics is doing, how the data is getting serialized as well. Then we got a bunch of interfaces or wrappers on top of the different destinations that we have. One of them, for example, is segment. And we basically create an interface, say, hey, this is what segment expects. It expects an event name, or a bunch of properties. So that's basically a contract. Now, how do we integrate that into our Android app? So there is a package inside your module in where you you define what code is specific for each platform, and then you create that the Android main package. And what we do here is to have the implementation of what is segment, right? So in the common main we have what is segment interface, but here is when we define what is actually the segment implementation there, right? So in this case, you can add any Android dependency here, because obviously we are relying on external party vendors. So we are going to use a specific SDK, which can be segment or can be Firebase SDK there. So that's when you use your Android specific implementation or dependencies. So all that gets compiled into an AAR or a jar, and it gets it can use on the Android app as any other module. So for all of you who are familiar with Android development, you probably this is nothing changing from what you currently do, except for this common main and Android main difference. So, but you might be wondering, what about iOS, right? Where is the iOS part here? And this is probably the big benefit of using KMM, is that you can just provide what is the iOS specific implementation, right? In our case, we have a different segment implementation for iOS because we rely on an iOS SDK there. But everything else is common. And yeah, so basically we provide a segment implementation for iOS. We use that SDK there, and that gets imported as a library for our iOS app as an XC framework. And then you can even publish that XC framework or the framework with CocoaPods or Swift Packer Manager if you want. So nothing changes from the iOS app point of view. So if you want to see a little bit of code, next slide is gonna, for example, this is what we have on the common main, for example, a bunch of definition of what properties are expected for this, for example, the product property, a bunch of properties there. What events we have, you add product events, which uses a product property, and this is an event and it has a name and type and all that. Everything, all this is defined on the common main. Then we have our analytics interface, which is expecting, to track an event. And obviously, this is the important part, the segment wrapper, right? So we just define on the common main what is this vendor gonna, how it's gonna send information. So basically, you just define an interface, and that's it. And from the implementation point of view, it's very simple. Then we just pass an event, and that event is using a segment wrapper, and we set that event to them. That's all what it does in the common part. Now that the fun part is here, like what about iOS, right? So on iOS, we just have to implement have an implementation of the segment wrapper, and you see here that is an iOS import. So which gets compiled into Kotlin, and then you define, okay, for this particular library that is going to send for what your library is expecting to do. And what about Android? So you will have defined an Android implementation as well on Android main, which is going to use obviously in the Android SDK import for that library. So yeah, that's basically it. And then what was the challenges? What were the challenges when we were doing this? The slow initial iteration, yeah, you will have a lot of fun in the beginning. The first hours of the first day is going to be a lot of trying to get the right configuration for that KMM module. But once you get that sorted, then you are all good to go. Well, you might have some errors as well, importing dependencies using CocoaPods. So we fall back to adding the dependency as the framework there. So we actually got the segment framework in the KMM module. And KMM has the flexibility to choose any of those. You can add it as a CocoaPods or have the whole framework in there, and it will compile it for you. The other challenge is that pure Swift dependencies are not yet supporting the KMM module. So yeah, it's something that you have to evaluate. But you can also, it's not a blocker. You can also have that implementation not on the Kotlin multi-platform level, but instead having the implementation on the platform level. So that that can resolve your problems there. Key takeaways. I would recommend start really small and iterate, on top of what you have there. Analytics is a really good candidate to start with KMM. It's not as complex as other part of your applications. Structure your code base, thinking about that there are some things that are platform independent and some other things that are not independent. So if you got that thinking since the beginning, it's going to be much easier to support multiple platforms on your way. Another thing which is very important is also plan how you're going to distribute your binaries. Depending if your project is already using CocoaPods, then you have to plug that in, or SPM, Swift Packer Manager, right? So for Android, it's not a problem. You can you publish that to using Maven Central. Nothing new for Android. And well, depending on the use case, you might want to have a platform implementation on the KMM module, or you might also have that implementation on your platform code base. For example, if the segment SDK is not available on Objective-C, we probably have to do that implementation on the iOS side of things instead, and we can use the Swift implementation there. And yeah, that's it. Thank you. Any questions?
Can you hear us, Carlos?
Yes.
Yes. Okay.
But I can't see you, but I can hear you.
That's right. I'll help relay people's questions. Any questions from the audience? No questions. Oh, Luke.
You said in your presentation that you talked about starting small, and you said that the analytics is like a really good candidate for this. So I'm assuming from that you've got plans to start using KMM more widely throughout your code base and doing more than just the analytics with it. What do you see as the big blockers to using KMM more widely for larger parts of your code base?
Did you get that?
Yeah. Yes. That's a pretty good question. I think from it has to be up to the team, I guess. So if all your team, your Android team and your iOS team are convinced with the technology, then you can start sharing more, because it will require communication with different people there. And then also you gotta have support from the business as well. So it's not if you're gonna share more things, it means that you're gonna invest more in that platform, and that has to come as well, from a bigger investment in terms, from the company to support that growth. But from the technology part, I guess there is nothing stopping you to share more code. I've seen other teams sharing more than the 50% of the code base. But yeah, I think it depends on each team, and what is your stage at your company in terms of the support to use multi-platform.
Thanks. Any other questions? Oh, up there in the red shirt.
Yeah.
I'll
Marvin. Just a quick question. So we're talking about here all the happy paths.
Yep.
Is there any drawbacks or anything that you think must still be improved with regards to multi-platform Kotlin that they haven't done yet?
I assume you didn't hear that one. So that question was about, we've looked at all the happy paths. Is there anything that could be improved for the non-happy paths in Kotlin Multiplatform?
Yes. So I think it was part of the challenges, probably. Like, for example, the Swift interoperability is something that you have to really look at. So if you got a lot of Swift SDK, pure Swift dependencies, so you might have to change the way you design the multi-platform module. It's not a stopper, but you have to change that. And then I guess the tooling, I think it's been improving a lot. Like multi-platform has been there out for at least, it's going to be 4 years. And in the beginning, it was really, really hard to have the iOS part configured well, because you have to configure a lot of Gradle files there. But it's getting better. Like, it's getting a lot of tooling support from Android Studio or IntelliJ. So they're publishing a lot of updates into the plugins. I would say those two things: Gradle project setup, Gradle configurations, and Swift interoperability.
All right. We've got one more over here.
Are there any alternatives to this or something like that?
Are there any alternatives to this, something like Dart, perhaps?
Yes, we actually, when we did this prototype, we played not just with multi-platform, but we explore other techs. And what we found that is like using Flutter or React Native as well on top of our app. It basically, you have to share more than just the analytics part. So basically, you share a whole bunch of things, and then you have to opt out to things that you don't want. So that was the main consideration why we are leaning towards multi-platform compared to the other ones.
Awesome. I think we might leave it there. Thanks very much, Carlos.